Alright, this will be your last video for the unit. This one's going to cover limiting reactant and limiting reagent problems. These do take a lot of work. They're not necessarily hard, but you do need to understand the process because we can ask you a lot of questions based off of limiting reactants. So limiting reactant is the limit on how much of the product can be made. So it's the maximum amount that can be made. So how do you know if you have a limiting reactant problem? This is really simple. You will be given amounts of both of the reactants. So you're going to have two givens, one for each reactant, and ask to find the amount of one product. You can actually say 1 right there. So steps to solving limiting reactant is find the theoretical yield. That's what we've been doing this entire unit, so no surprise that we've got to do that. The next step, step 2, is to figure out which is the limiting reactant. So you see which made the least amount of product. So remember, that's the most we can make if it's the smallest amount possible. Step 3, to figure out if the limiting reactant is left over, it will always be none. So you should really like those questions. There's never any of the limiting reactant left over because we used it all. And step 4, to figure out the amount of excess left over, this one's a little bit weird. You take the amount of limiting reactant you used, and then use stoichiometry to calculate the amount of excess reactant actually used. Then you do the equation had minus leftover, or had minus used equals leftover. So that doesn't make a whole lot of sense until we actually start going and doing some practice problems. We'll jump right into it. So number 1, 15 grams of hydrogen mixed with 40 grams of oxygen to form water. This is a reaction you should know by now. It's 2H2 plus O2 yields 2H2O. So what is the theoretical yield? Well, the first thing it gives us is 15 grams of hydrogen. So we're going to start with 15 grams of H2, and we're going to find the yield of water. So we're going from H2 to H2O. So go to moles, so it's 2.02, it's the molar mass. So 1 mole H2O. Next step is the mole ratio, 2 moles H2 to 2 mole H2O. Now go to grams of water. 1 mole H2O equals 18.02 grams H2O. That gives us 133.81 grams of H2O. But we have two givens, because now we've got this one right here, 40 grams of oxygen. So you got to start with 40 grams of oxygen in a whole other problem and go find out how much water that will make again. So that's molar mass of O2, which is 32 grams of O2, and every 1 mole of O2. Next step is the mole ratio. It's going to be 1 to 2 ratio. Convert to grams of water. And that will give you 45.05 grams. So now, what is the limiting reactant? Remember, it's going to be the smallest amount. So we got 133.81 from the hydrogen, 45.05 from the oxygen. So oxygen, because it made the smallest amount, is going to be our limiting reactant. Get there. Go straight to my website. Okay, next question. How many grams of limiting reactant are left over? This one's always easy. None, because we have used it all. Next one, how many grams of excess reactant are left over? This is the weird one. We're going to start with with how much limiting reactant you had. So we ended up with 45.05 grams of H2O. Now we're going to end up going back to how much of our excess reactant we have. So we're going from grams of H2O back to our excess reactant, which is going to be H2. So we're going to grams of H2. So more stoichiometry, 45.05 grams H2O. Convert to moles using molar mass, so 18.02 grams of H2O. Every 1 mole of H2O. Mole ratio, it's going from 2 to 2. 2 mole H2O to 2 mole H2. And then convert to grams of H2. That will give you 5.05. That'll be grams that you actually used. Now, you're not done yet, but it says, way back up here in the top left, that you started with 15 grams. So you had 15 grams, you used 5.05 grams, and that's going to give you 9.95 grams of H2 left over. So that is your final answer right here. Remember, this was had minus used equals left over. So the next one, what was the percent yield of this experiment? If we had 43.0 grams actually collected, remember it's actual over theoretical times 100. So 43 grams was actually used, so 43. And then we use our limiting reactant, 45.05, for the theoretical. And then don't forget to times it by 100. Sorry, I did change. That will give you the 95.45% yield, which is actually very, very good. All right, so you got one more question. Let's run through it real quick. All right, so 35.6 grams of zinc react with 100 grams of copper sulfate, forming zinc sulfate and copper. So you got to write the balanced equation. Start off with zinc plus copper sulfate, copper 2 sulfate, yields zinc sulfate and pure copper. All right, what is the theoretical yield of pure copper? So we're going to start with 35.6 grams of zinc and end up with pure copper in grams. So convert to moles using molar mass, which is going to be 65.41. 1 mole. The conversion factor, or the molar ratios for these, is very easy because they're all ones. Everything's a 1. Now convert to grams of copper. So first reaction gives us 35.49 grams of copper. We're not done yet. We got 2 givens, so we got to go with 100 grams of copper 2 sulfate and find grams of pure copper. So convert to moles using molar mass. Mole ratio is 1 for everything in this problem. Then convert to mass. And that gives us with 39.8 grams of copper. So what is limiting reactant? Well, our lowest answer is 35.49, and that was made by the reactant zinc. So zinc is limiting, which means the other one is excess. The other one is copper 2 sulfate. So how many grams of the zinc will be left over? Well, zinc is limiting, so that one is always none. And the excess reactant we left over, remember you start with your theoretical yield, which is going to be 35.49. Convert that to moles, and molar mass. Mole ratio is easy. Will give you 86.88 grams used. So you had 100, you used 86.88. That leaves you with 13.12 grams left over for the copper 2 sulfate. There you go. So you just got to know what you're starting with, what you're ending with, and make sure you really understand the stoichiometry. This is really that bad. Right, any questions you got? Bring them to class.